घटनाएं जो भी इस समय लगातार घट रही हैं उनका बारीकी से अध्ययन किया जा रहा है। और जिस समय हम करीब करीब 1:38 सुबह के हम चंद्रमा के उस बिंदु पे पहुंचेंगे जहां ऊंचाई करीब करीब 35 किलोमीटर होगी, उसी क्षण में ऑर्बिटर भी जो होगा वो बिल्कुल उपग्रह के ऊपर होगा, इस तरह से ताकि हम उसके चित्र प्राप्त कर सकें।
So minus 3 minutes 53 seconds before we start the power descent operation. Just to give a quick update on the way the total power descent operation for the Vikram lander would be carried out. The descent operation would, as you can see on the screen, we are at 3 minutes to go before we start these operations. So Vikram lander would commence from an altitude of 30 kilometers, and once this descent operation has started, it will be for a duration of nearly 15 minutes before it touches down on the lunar surface. And the Vikram landing sequence is achieved through an autonomous landing sequencer. And just to give an update, the final state vectors and other parameters have already been loaded into the Vikram lander 4 hours prior, so it's all ready to go and start its operations. So as per the power descent plan, it's expected to start at 1 hour 38 minutes Indian Standard Time. As I mentioned, we are just less than 3 minutes now. And this entire power descent operation will be carried out in 4 different phases of operation, namely the first phase, which is the phase referred as rough braking phase, will bring the spacecraft from 30 kilometers to an altitude of almost 7.4 kilometers. The second phase after the rough braking phase will be attitude and absolute navigation control phase, which will enable the spacecraft to travel from 7.4 to 5 kilometers. And then immediately we will have the third phase of operation, which is the fine braking phase, where we bring down the spacecraft from 5 kilometers to almost at an altitude of 400 meters above the surface where the landing is supposed to happen. And eventually from 400 kilometers, the vehicle, the spacecraft will not have any forward moving velocity. It will be only used to have a vertical descent for a touchdown. So the final phase of operation after the fine braking phase will be the terminal descent phase, where the Vikram lander will be brought from an altitude of 400 meters to 100 meters to 60 meters to 10 meters and finally the touchdown. So as we go through these operations, as I mentioned, it will be a 15 minutes of descent operation. Once the activity is initiated, we will be bringing you some of the flight parameters and the status, how the total operations are going on. So each of these phases during the power descent are very critical and important in its own way, as it has a very specific objective and the goals to be achieved during this entire phase of operations. So maybe another 1 minute, 19 seconds to go. The further update as far as the descent operation is concerned, the Vikram lander has 4 main propulsion engines, each generating a thrust of nearly 800 newtons. And out of these 5 main engines, the 4 engines are throttleable liquid engines, which means we will be able to regulate the thrust of the engine, like increasing the speed or decreasing the speed of the engine to achieve the required deboost velocity. Another 48 seconds to go before this deboost or firing of the engines. The 4 thruster engine, throttleable engines are carried out.
जी हाँ, थोड़े तनाव भरे क्षण जरूर हैं, क्योंकि हम बेहद करीब 32 सेकंड के जब विक्रम को धीरे धीरे उतारा जाएगा नीचे, लेकिन सबसे महत्वपूर्ण हो जाता है कि कैसे उतरते समय उसके वेग मान को कम किया जा सके, जिसे हम रफ ब्रेकिंग फेज कह सकते हैं। और इस रफ ब्रेकिंग फेज के दौरान हम जो उसमें लगे हुए 8 थ्रॉटलेबल इंजन हैं, जिससे उसके प्रणोद बल को कम किया जा सकेगा। ऐसे 4 इंजन 4 कॉर्नर पे लगे हुए हैं, 4 कोनों पे लगे हुए हैं, और ऐसा ही एक 800 न्यूटन का इंजन जो है बीच में लगा हुआ। और बिल्कुल हम करीब इस समय विक्रम डिसेंट के स्टार्ट कर दिया गया है, और रफ ब्रेकिंग जो वो है घड़ी है, वो बहुत ही नज़दीक होगी। इस समय हम धीरे धीरे अब उसकी गति को कम करना शुरू करेंगे।
Yes, the descent phase of operation for the Vikram lander has just been initiated with the firing of the 4 liquid engines, which I was mentioning, the 4 throttleable engines. The activity has just started, and right now we are at 35 seconds since the engines have fired. And just to give an update, the Vikram lander, when it was in an orbit of around 30 kilometers, when the descent operation started, it had a velocity of nearly 1640 meter per second. So what we are going to do through this entire phase of 15 minutes of operation, when the power descent will be done, is
open free DMAT account instantly.
Surface of the moon. So the activity has just initiated. As you can see on your screen, the view of the Mission Control Center with Chairman ISRO and Director of URSC and Dr. Suresh briefing the Honorable Prime Minister about the flight event that are going on. So the time elapsed is almost 1 minute 28 seconds.
जी हाँ, धीरे धीरे गति कम होती हुई 1507 मीटर प्रति सेकंड हो चुकी है, जबकि हमने 1630 मीटर प्रति सेकंड की गति से प्रारंभ किया था और हर घड़ी की, हर क्षण की जो जानकारी है वो प्रधानमंत्री को पहुंचाई जा रही है। और इस समय हम करीब करीब 1 मिनट 52 सेकंड का समय व्यतीत कर चुके हैं और वेगमान लगातार घटता हुआ, और यही उद्देश्य भी हमारा है कि धीरे धीरे जो रफ ब्रेकिंग है उसके दौरान चारों जो इंजन हैं, उन चारों 800 न्यूटन वाले इंजन जो भारत ने पहली बार विकसित किए हैं, ये पूरी जो प्रणोद प्रणाली है ये पहली बार विकसित की गई है और इस प्रणाली के चारों इंजन लगातार फायर करते हुए, प्रज्वलित होते हुए और लगातार वेगमान घटता हुआ।
So almost 2 minutes 20 seconds, and we expect this rough braking phase which was just initiated to last for nearly 10 minutes, during which time the velocity, the orbital velocity which the Vikram lander possessed of the order of 1640 meter per second should reach to something like 140 meter per second at the end of the rough braking phase. So basically during this phase it's a real brute force of operation where we are trying to kill the velocity which the spacecraft currently has, making it revolve around the moon with an orbital altitude of 30 by 100 kilometers. So I am seeing on my screen that the velocity from 1680 meter per second has come down to almost 1300, so nearly 350 meter per second velocity for the Vikram lander has been reduced. 3 minutes have elapsed, and maybe another next 7 minutes we should have quite a substantial reduction in the velocity to ensure that at touchdown we have almost near 0 meter per second velocity, to ensure that the Vikram lander has a soft landing on the surface of the moon at the very desired landing site location. So we are right now in the rough braking phase of operation, nearing 3 minutes 39 or 40 seconds, and almost I would say 480 meter per second velocity has been reduced, which is clear indication that the entire operations during which the 4 throttleable engines are being fired has been performing absolutely nominally, and the reduction in the velocity and the down range, the range it has to, after the descent operation has started, it has to cross almost a range of 600 kilometers before it lands at a predefined destination. So I am seeing a very close match with the pre-flight and the flight prediction. The velocity of the Vikram lander has come very close to 1100 meter per second. So almost to 500 meter per second velocity reduction has happened in just 4 minutes. So another 6 minutes to go before we reach in the mission objectives of the rough braking phase.
जी हाँ, करीब करीब 6 मिनट का समय 4 मिनट का समय व्यतीत हो गया है। 6 मिनट लगभग और वेगमान कम करने के लिए लगेंगे। इस समय करीब करीब जो सारी गतिविधियां हैं, सारी प्रणालियां हैं, वो अभीष्ट रूप से चल रही हैं। इस अवतरण को सुरक्षित और कोमल या सेफ एंड सॉफ्ट लैंडिंग बनाने के लिए अनेक अभिकल्पनाओं पर विस्तृत चर्चा और गहन अध्ययन के पश्चात ही विशेषज्ञों ने अनुमति प्रदान की थी। इसरो के लिए ये सबसे बड़ी चुनौती है, क्योंकि इसरो ये पहली बार करने जा रहा है। इसके लिए प्रोपल्सन, ऑनबोर्ड कंप्यूटर, सेंसर्स, स्ट्रक्चर, मैकेनिज्म, थर्मल जैसी अनेक प्रणालियों के उचित सामंजस्य से ये सब कुछ संभव हो सकेगा। और सबसे बड़ी और महत्वपूर्ण बात यह है कि ये सारी गतिविधियां स्वचालित रूप से चल रही हैं। इस दौरान लैंडर में लगे अनेक संसूचक जरूरत के अनुसार आंकड़े उपलब्ध करा रहे हैं और ऑनबोर्ड कंप्यूटर उचित गणना के आधार पर यथोचित निर्णय लेकर लैंडर को चंद्रमा की तरफ उतरने में सहायक सिद्ध हो रहा है। करीब करीब 939 मीटर प्रति सेकंड